So this video explains how you can define a configured model and drive Liftdesigner parameters based on this model. Let's first have a look at this configured model. We have defined an elevator with a car and a counterweight, and the counterweight has just one parameter, which is distance between guide. The car has two parameters, car width and car depth, and a relation table that says which car depth which fits to which car width dimension. And then there is also for the wall 2, which is the rear wall, we have up to 4 panel width dimension parameters. We have the rear wall panel count, and we have a panel material that can be glass or steel. And on top of that, we have a car width to panel width table. So based on the car width, we determine the panel count, the panel 1, 2, 3 width, and for demonstration purposes we have assigned a material. So for the 3 small sizes we have a steel wall panel, and for the 3 large sizes we have a glass material. Also we have assigned the distance between guide of the counterweight. This probably does not make too much sense in this scenario, but it's just for demonstration purposes. If we compile the model in the configured modeler and we debug or configure that, you see you can choose a car width, and then only the related car depth that is possible is shown up, or if we choose another size we can choose from other sizes of car depth, and then the panel count and the width of the different panels and the materials automatically assigned from configured. So if we have a 1000 millimeter size, and then you see it's a steel material. Also from the relation table from configured, the related counterweight width is calculated. So now let's have a look at the Liftdesigner model. Based on this table that we had before, we have a car width of 1000 millimeter and the panel width is 500 and 500. So if we change this to 1400 as an example, you see that we have the width dimensions that were assigned in the 1400. Let's have a look at the model again. Car width to panel 1400, and you see it's 500, 400, 500. If we see this in Liftdesigner, you see 500, 400, 500. Also we can see it's a steel material. This is also taken from the configured model. Let's say we have other dimensions here. Let's say it's 600 and 200 and 500, just as an example. Then you see we have to compile that. If we recalculate the model in Liftdesigner, this is automatically updated. We can also see something went wrong. It's not enough. So the user who develops the configured model can immediately verify the results of his configuration definition. So let's put a 300 here, in case this should be the correct size. Then we see that it's automatically updated accordingly. Another option is that we have some reporting here. We can pin that, and we can see that there is some configured checks. And if we put, let's say, 1100 here, then you see that it says there is no valid car depth. There is only 1400, which is a valid value. We can automatically apply this, or in this case we show it as an error message, and you can change that, and then you see the synchronization with configured is working fine. If we go then to the 1600 size, you see something is wrong because 1600 is no valid car width. So we have to fill in a proper value to make the model work properly. What we can also do here is we can also show the rules from configured. So you see here we show the different car width dimensions, so we can put a 1200 here, and then based on that we can only select what is possible in this relationship. So this table is automatically populated based on this configured model. As you remember from this initial presentation, I showed you that we also assigned the the distance between guides dimension from the car width. So you see we have 1300 here as a distance between guides for this related car size. So if we change the car width to a smaller size, 1200, you see that also the distance between guides of the counterweight is automatically changing. So at any time when you change the car width, the distance between guides follows accordingly. And what I want to show you is how you can now use a Solidworks model and drive the parameters of the Solidworks model based on the configit-Integration parameters. So let me show you how that works. First, we replace the simplified Liftdesigner bracket with a rail bracket that has been developed in Solidworks by the R&D developer. So we add this rail bracket product, and you see this is immediately loaded here in the model, but it has a wrong direction at this point, so we can rotate this a little bit to bring it in the right location, and we will disable the default DigiPara Liftdesigner simplified model. What you see now is that the bracket is in place, but it has the wrong size. So what we need to do is we need to assign a mapping, and therefore Liftdesigner has a tool which is the mapping wizard, and you can simply choose the rail bracket parameter Excel file that is related to this component. And here in this step number 3, we can now assign the parameters. Let's say the guide rail height. So we select the mapping parameter from the Liftdesigner model, which has the counterweight, guide rail list, and the guide rail height is found in this node, which is GDH1. And the same we do for the distance between guides parameter. So let's go to the counterweight table, and then there is a DBG dimension which is 1000 currently, and there are 2 more parameters that I have to assign, which are the distance from the wall to the guide to the counterweight, and then so there is this counterweight there is this Y1 dimension, and there is another which is quite similar, which is the Y2 dimension. And once we have that, it gives me an update what needs to be updated, and update CAD model in external CAD program is enabled. And what happens now is that Liftdesigner automatically starts Solidworks, opens the model, and updates the parameter in the Excel file and updates the Solidworks construction. You will see that right now. So this is standard Solidworks operation to update the model, and then we are back in Liftdesigner soon, and we have an updated model here. In the 3D model, you can now see that this bracket has been properly updated and is placed in all vertical locations as well. So let's make the sample and give it another size. So if we go to the car size and change this to a smaller size, let's say 1200, then you see that the distance between guides has changed, and I have to once again rerun the model to update this. I will show this in a second. In the meantime, I want to show you that we can, or at any time, we have the design of this component, but we also can see the flat pattern at any time. So in the moment when this is updated, we have immediately the flat pattern for production purpose. So let me close that all here. And let's run the update in CAD model process again. So this will then once again run your SolidWorks model and generate everything. So Liftdesigner can drive the whole model and can automatically rebuild the model and the production materials, as you can see here right now. Once you have completed your design, at any time you have the different views and installation drawings. So we see that in the installation, the final installation drawing, the bracket is installed here, and we have these components available in all models. So in all drawings that are related to this design, we have our rail bracket in place. We can export this as a BIM model, and also all cabin details are properly in place. And what I told you before, at any time you can change sizes. So if you have a bigger size, then you see there is some glass element, and you also have a cabin approval drawing available at any time. Thank you very much.